Hello, I welcome you all to this another interesting screencast. Determine the support reactions at a smooth journal bearing A, B, C of the pipe assembly. This problem is coming from the Engineering Mechanics textbook, 13th edition by R.C. Hibbeler. Let me speak a little bit about the journal bearing. Um, so imagine you have a journal bearing like this one here, okay? And then you have a member like so. Member coming in. Let me just finish this one. So imagine you have a rod and then it comes out like so. Alright, you have something like this, and then you have a rod that comes out the other side like that. Okay, and if this is your z-axis, and then let's say this is your y, this is your x. If you are to write the reaction forces here that you expect if this point is A, of course, you say this is your AZ, and then you say this is your AY. It is free to move in the X direction, and then you also say you're going to expect some couple moments or some moments there. You have MZ, okay, and you also have MY. All right. This is where you just have a member that is not supported elsewhere. But the moment this particular structure is supported elsewhere, you can neglect these moments. All right, you can neglect these moments. You don't need them, okay? They're as good as they're not there, okay? Because you're just going to have unnecessary work. So you can neglect these particular moments if this particular structure is supported elsewhere, right? Because they'll still be equal to 0, right? I wanted to talk about this because I received a question regarding these journal bearings. Okay, so let's draw the free body diagram. We're going to have at A, we'll have AZ. Then in this direction, we are going to have AY. Along the X, the bar is free to move, or the structure is free to move, so therefore will not have any reaction. At B, we'll have BZ. Okay, it's not very clear line, right? Maybe let me put it somewhere there. We'll have BZ, and then in this direction, we're going to have BX. Then here we'll have maybe here we'll have CZ, and then in this direction we're going to have CY. Okay, so those are the reaction forces. So this is again a 3D rigid body equilibrium problem. A 3D rigid body equilibrium problem. And how many equations of equilibrium do you expect in 3D? 6. Summation of forces in the x, y, and z, and summation of moments in the x, y, and z. How many unknowns do we have? We have 1, 2, 3, 4, 5, 6. Oh no. But you don't have to worry. Let's just apply the equations of equilibrium, and if we are consistent, everything else will flow. So we have summation of forces in the x equal to 0. Okay, in the x, let's look at what we have. In the x, we have bx. What else is in x? What else is in x direction? The forces, we only have one force here. and so Bx is just going to be equal to 0 what? 0 newtons. Okay, then summation of forces in the y equal to 0. In the y, what do we have? We have Ay, then we have Cy. What else? Anything else? That's about it. So this is equal to 0. Then we have summation of forces in the z equal to 0. What do we have in the z? We have Az. We have Bz. We have minus, plus, Cz, and then minus the one I wanted to indicate, 450 equal to 0, right? We have 1, 2, 3, 4. Great. All right. And then let's now work on moments, summation of moments about the x-axis. We are using the right hand thumb rule for the direction of the moments. So about the x-axis, which forces are going to cause a moment? About the x-axis, we have Bz. Of course, Az and Ay will not cause any moment about the x-axis because their lever arm are equal to what? 0. So Bz will cause a moment 450, Cz will cause a moment. Yeah, so we have 3. Bz, 450, and Cz. Okay, so let's work them out. And then Bz, using the right thumb rule, Bz is causing a positive moment. So we have Bz times the lever arm. What's the lever arm? It is 0.6. And then 450, it will just cause the opposite, which is negative, and the lever arm is 1.2. Okay, and Cz will cause a positive. Okay, it's in the same direction like Bz. Cz, so Cz times the lever arm. What's the lever arm? The lever arm is 1.2. All right, what else? So we have Bz, 450, and Cz. These are the only three forces that will cause moments about the x-axis. Right. Great. So let's move on. So we have summation of moments about the x-axis. I mean the y-axis. Y-axis, Az and Ay and Bz will not cause any moment about the y-axis. Which forces will cause a moment? Bz is one of them, 450 is one of them, and Cz. Alright, the same forces that cause the moment about the x, right, also cause moments about the y-axis. This time around, Bz is going to cause a negative moment. Bz will cause a negative, so it will be minus Bz times the lever arm. What's the lever arm? The lever arm again for Bz is 0.6, and then 450 is causing a positive one, so it is plus 450 by 0.6, and Cz is a negative one, Cz by 1. Okay, 0.4 plus 0.6, that's 1. Alright, equal to 0. Alright, then we have finally summation of moments about the z-axis. Which forces are going to cause moments about the z-axis? We have Cy and we have Bz. Okay, so we have 2 only, the rest will not cause any moment about the z-axis. So we have Bx and Cy, right? So using the right thumb rule, Bx to cause a negative, so it will be minus Bx by 0.6. Okay, and then Cy, it will cause a positive, so it will be plus Cy by 1, okay, equal to 0. All right, so now we need to solve these equations. All right, so let's solve these simultaneously since we only have dz, and so we want to solve these two equations. We want to solve the two, so let's generate these two equations so that we solve them simultaneously. So let me just work them out. So we have, let me make dz subject to the formula so that I can fit it in one of the equations there, or we can just say 0 0.6. I'm working on this one. So 0.6 bz, okay, like I said, I'm working on this one right now, simplifying it. Okay, so bz minus plus 1.2 cz, and then minus 415 by 1.2 minus 540 equal to 0. Then let me work on this one at the bottom. This one gives us a 0.6 bz, this is a minus, and then plus, minus cz, and then plus 450 by 0.6, this is a 270, okay, equal to 0. So we can use substitution method. We are going to sum them or add them. So this part gives us a 0, this part gives us and that's a 1 minus 1 is 0.2. This one gives us a 0.2 plus a 0.2 cz, and then the 2 minus 540 plus 270, this gives us a minus 270 equal to 0. Therefore cz is just going to be equal to 0.2 divided by 0.2. This gives us a 1350 1350 newtons. Right, so we have cz, we have found cz. So what we need to do now is to find bz. So our bz, therefore let's plug this in one of these equations here. We'll plug this, let's plug it here. All right, and once we do so, then we'll find that our bz is going to be equal to, so we have 1.2 by 1350 minus 540, and then divided by 0.6, then we have bz equal to minus 1800 newtons. Okay, so we have 1200 by 1.2 minus 540 divided by 0.6, so we have that value there, 1800. So now since we have cz and bz, we can feed them in here in this equation. We have bz equal to minus 1800, and then we have cz equal to 1350. So we have this equation, we are going to have az equal to we have a minus 1800, then plus 1350 minus 450 So Az is just going to be equal to 900 newtons. Okay, let us now find the other values. We know Bx is equal to 0. We can come to this equation here. Let's come to this equation here. Okay. So we know that Bx is equal to 0. Therefore, Cy will just be equal to 0 newtons. Okay. Then let's come to this equation now. This equation. Okay. Since we know that Cy is equal to 0, therefore you expect Ay to be equal to 0 newtons. So let's replace these values here. Let's start with Az. What is our Az? We said Az is equal to 900 and it maintains the same position. What is Ay? Ay, we found Ay to be equal to 0. Okay, what is Bx? Bx, we found it equal to 0. What is Bz? Bz, the direction changes. So the direction, it will be like so, and this is equal to, it's going to be equal to 1800. All right. Let's come to see what is Cz. Cz is equal to 1350, and what is Cy? Cy is equal to 0. Right. Let's have a quick check. Summation of forces in the x, we have a 0 in the x. In the y, we have a 0 and 0. Okay, and then in the z, we have 900 Az, and we have let me just write this one. I take it up like this. Yes. All right, and then we have 1800 there for Bz. Okay, and then what else? We have another value which is a 450. Then we have this one which is so let me sum up 1350. 1350 plus 900 gives us 2250. 2250, and then 1800 plus 450, 2250. Great. So everything else sums up. Let's now outline the final solutions. Of course, Bx is just equal to 0. Ay is also equal to 0. And Az is equal to 900. What else? Cy is equal to 0. And Cz is equal to 1350, and Bz is equal to 1800. Right, this is really about it, and I hope the video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast.